And welcome everybody to the Daily Space Weather. Congratulations on realizing our channel exists. We've got more spectacular imagery of the sun, analysis of the data, and lots more. Here's the Northern Hemisphere in ionized helium from the Solar Dynamics Observatory. How about the Southern Hemisphere? We've got it. There was an M-class flare generated from that sunspot 2871. That bright region you see moving into the center part of your screen. So 2 M-class flares out of this. By far the most X-ray activity we've seen for months. Likelihood of additional flares continues, and we're going to raise a coronal mass ejection watch. Here's your colorized magnetogram. We're going to zoom in a little bit. This is just the last day. So we've got 4 sunspot groups right now, 4 of them, folks. And 2 of them are major, these 2 here. And they're moving right into the Earth-facing zone. Again, solar flare watch in effect. Coronal mass ejection watch now in effect as well. Here's the Northern Hemisphere in a different wavelength. This is ionized iron. The low corona, 171 angstroms, ionized iron from the Solar Dynamics Observatory. Southern Hemisphere is where the action's at. And a great view of that M-class flare. Right at the end of the video, there's a C-class flare as well. I'll let that play through one more time here before we move on and blast through a whole bunch of data. One last view here from the SDO. It's 171 angstroms, the full disk image. The radio flux has come up to 90 solar flux units. Here's the 1-year chart of the radio flux. Yeah, the upper chromosphere and lower corona, they emit radio waves. We call it the F107 or the F10.7. Anyway, the black line is the 10.7 centimeter radio flux. The red line is the sunspot number. And we're seeing some forecasts here for geomagnetic storms on the 26th. Not sure what that's about. Is that because of a coronal hole wind stream, perhaps? Must be. So expecting an additional coronal hole wind stream there on the 26th. I don't know what their model is all about. I'm just going to move on and not dwell on it. Next, looking at global seismicity here, we've seen some 6 magnitude quakes. There was not a 9.5 magnitude quake yesterday. That was some kind of a misreport at Argentina. Thanks for the heads up, Mary. We did see some deep quakes indeed, like this 4.6 at Fiji at 546 kilometers. How about this 4.5 at Chile at over 100 kilometers? How about a 4.6 at Papua New Guinea, 256 kilometers estimated depth there? Some earthquake activity here north of New Zealand as well here, in between New Zealand and Tonga. So the Kermadec Trench and the Tongan Trench separate New Zealand and Tonga. That's a common spot for earthquakes, indeed deep earthquakes in that ocean rift zone. So no quakes over a 6 magnitude here in the past 24 hours. Some mid-5 level earthquakes happening though. But if a volcanic uptick here continues, we're going to show some volcanic gases later in our meteorology segment. Make sure you watch that. Those premiere before our daily space weather video most days. La Palma volcano still exploding, producing a 10,000-foot ash plume, and being the world's leading source of sulfur dioxide. Again, we'll show some atmospheric chemistry in our meteorology segment. Karimsky also erupting there. That's an uptick at Karimsky as it explodes. 26,000-foot ash plume, one of the Highest levels of activity we've seen from Karinsky in quite a long time here. Suwanose Jima also exploding. Flight level 120. Popocatépetl dispersed its ash, fertilizing central Mexico. Fuego produced a pyroclastic flow during an effusive explosive eruption. Hopefully nobody was near that. Pyroclastic flows are not a way to go. Deadly, turbulent, hot avalanches of lava rock fragments of all sizes and a mixture of turbulent gas and ash racing down the slopes. Don't be in the way of that. It'll be probably your worst day ever. Also, 2 new lava flows there, so significant uptick there at Fuego in Guatemala. Please don't build a campsite on the lower slopes of Fuego. It could be an unfortunate day. Revenador also exploding in Ecuador. Flight level 150, and intermittent emissions from Sabancaya are a reminder to not pole vault the caldera. I don't care how athletic you are. I don't care if you want to be Steve Stimpak. Please don't pole vault the caldera. While there are no stupid questions, there are stupid people. And you never know quite how dumb they'll be. So, since, of course, you're not stupid, our viewer, please tell your friends and foes about the channel. Tell your friends and foes not to be imbeciles. Please don't pole vault the caldera. We need the views on YouTube. Anyway, there are a bunch of products. You can find links to that at smashomash.com. Click the smAsho merch link, or perhaps click the Smash Team link if you want to support us that way. And get all kinds of information on the internet nobody else gets to see. We've replaced Patreon in the month of Smashtember. Smashtober will just be better than Smashtember, which has been spectacular, by the way. A spectacular month of Smashtember. Happy Smashtember, viewers. Ghost magnetometer showing some spiky sawtooth patterns here as there's been a coronal hole wind stream and a coronal mass ejection in the past couple of days here. So yeah, some activity there in the ghost magnetometer as there's a bunch of plasma of the high-speed variety currently arriving. Let's take a look at the heliospheric current sheet polarity. There is a North Pole current sheet on the way, likely, I think, folks. And don't be surprised to see the northern sunspots continue to degrade here. I believe there is a North Pole current sheet on the way. Anyway, there's the current state of affairs. Could be a serious activity here out by stereo A. If you look at this bulging here in the magnetic field force lines, this sort of empty-looking spot right here is highly suspect of a sunspot. So we may see another highly active region rising in the east of the sun coming soon. Here's a line-of-sight view of the same data, the line-of-sight ecliptic plane field plot. Shows you the solar magnetogram. Don't be surprised to see this blue line dipping down in the coming days. That's called a forecast. We like to look at things like predictive value on the channel to produce some actual science. Next, looking at the line-of-sight coronal hole plot. South Pole-oriented coronal holes shown here in red, dominating the southern hemisphere of the solar disk. So here you can see them. We've put up, that is a 3-day animation. And the coronal hole wind stream currently arriving is from this South Pole well-defined coronal hole down here. We can expect to see this current coronal hole wind stream continue for the better part of the next 24 hours, I'd have to say. That's my guess. We'll get to the real-time solar wind momentarily. First, the flare monitor, the flare probability monitor, that is, and the detected sunspot group. So, again, the star of the star is 2871. It's beta gamma delta class. It's in a state of flux and likely to continue to produce major solar flares unless we see some sort of a degradation of the fields. Solar flare watch and coronal mass ejection watch are in effect as a result. So here's the X-ray flux over the past 3 days, and you can see there was just a C-class flare as I was getting out of bed today, and 2 M-class flares that occurred yesterday, the largest solar flares in several months, couple of months. No spikes in the proton flux. No relativistic particles have struck the Earth geospace as a result of any of those 3 significant flares. Next, the real-time solar wind. To show an elevated solar wind speed here, it made it up to just over 500 kilometers per second briefly, And now we're sort of at a more steady level here. 476 kilometers per second is the solar wind speed. Solar wind density, 11.27 protons per cubic centimeter. BT-BZ looks like it's continuing to shift here. Maybe going into the negative BZ territory, which could spark geomagnetic unrest or minor storms. Again, we expect to see this high-speed coronal hole wind stream to continue for, I'll say, 18 hours from the time we recorded this video. KP index only at 2. And again, if you see the BZ component, which is this red line in the top pane here, if you see that go strongly into the negative BZ territory, in other words, if that turns into like 8 and -6 or something like that, that might cause geomagnetic unrest or minor storms. The KP index is a measurement of global geomagnetism. Let's look at geomagnetism from the perspective of space. And we're seeing fairly homogeneous pressure here over the past 4 hours, I would suspect. This is called the Geospace Magnetosphere movie. We show them daily on the Daily Space Weather videos. We show all the data to immerse our viewers in it so they have a clue how it relates. Anyway, again, that's 4 hours of data. Here are ground magnetic perturbations. We showed you the sun's B field. Here is the Earth's B field, or changes in it. The B field is the field that goes through a magnet, folks. And we're talking about Earth as a magnet in this moment. Since there's a geomagnetic excursion going on that people are very unnecessarily frightened about, we show this 4 hours of data to show where changes in Earth's B field are occurring for the past 4 hours. Here's where stuff is in the solar system. No, planetary alignments don't control the solar activity. That's ridiculous. If you've got some physics to explain it, leave us a comment. We're going to advance this 1 week. And there's where things will be on the 1st of smAshtober. We've also put up a star chart here for all of you stargazers. Once again, congratulations on finding that our channel exists. This is in-the-sky.org. By the way, I face mine to the south. I'm currently facing the south, and so is my sofa. The blue line is the galactic plane, and the yellow line is the ecliptic plane, the path the sun will take across the sky. And the moon is up there over Lehigh Valley. Let's do a brief cosmology segment. We've picked a random number. It's 182, which coincides with a high-mass X-ray binary massive radio source on the Neil Gehrels Swift-Bat X-ray Observatory. I think it might be an eclipsing binary. It's LMC-X4, yes, the high-mass X-ray binary / believed to be neutron star. And if you look at how this cyclicity is so quite perfectly cyclic. It's a very cyclic cyclicity, indicating that it's probably an eclipsing binary. As you can see, the X-ray consistently inconsistent. However, quite consistent over the past 16 years. It's a very consistent X-ray source, and a very bright one at that, in the Large Magellanic Cloud, the satellite galaxy of the Milky Way. Let's take some looks at it here on the CDS portal. And here it is in infrared. Here it is in optical light. We're going to zoom way out so you can see the Large Magellanic Cloud. And we've zoomed all the way out. And it looks like this is actually on the outskirts of the Large Magellanic Cloud. LMC-X4. Let's take a look at it in some other wavelengths here. Oh, we're moving all around. I got to press refresh. Anyway, here are the photometric points. The points where this is bright. And you can see it's bright across most of the electromagnetic spectrum here. Lots of papers about this one, as it is you could say it's an extragalactic massive radio source. Here's some false color X-ray imagery of it. And again, you can see it is a very bright X-ray source there in the LMC, the Large Magellanic Cloud. I think this one does show up in infrared as well. Let's take a look at it in infrared, and you can see a little bit of a thermal signal there from the 2-mass. Once again, that's our featured quote random and quote object of the day. LMC-X4 in the Large Magellanic Cloud, the likely eclipsing X-ray binary, consisting of something like a massive radio source believed to be a neutron star and a white dwarf, most likely. I won't get into the physics of that. I'll just say it's probably a low plasma environment from that X-ray source. Here's the astronomy picture of the day. You can look at it yourself at apod.nasa.gov. I don't know why they're showing Perseids, as that occurs in August, but they're showing Perseids today for September 24th. That's today's cosmology segment. Let's move on with more data about charging hazards. We do see some minor charging hazards here at the moment. We did get into electron warning levels yesterday. I don't expect to see that today, as the coronal hole wind stream has arrived in full force. So here's the relativistic electron flux, the greater than 2 mega electron volt electron fluence reported by solon.info/solar. If you want to look at that yourself, it's a 1-year chart. And you can see this brief moment of electron warning levels here coinciding with 1,000 pulse flux units, or in this case, 1,000 particles per negative centimeter squared. Again, we don't expect to see this go back into warning levels today because of the coronal hole wind stream currently striking the geospace. This model is going to be incorrect. This is going to be back down here again, not up here. Tune in for tomorrow's video if you don't believe me, as I'm proven right. Here's a diagram of Earth's Van Allen belts. And I'm rarely wrong with these sorts of forecasts, folks. It's why we immerse ourselves in the data. Anyway, if you need to pause the video on that, feel free. Now we're showing you the total electron content forecast. The entire air column from your GPS satellite down to your handset gives you a forecast of where likely GPS errors will occur. They usually occur around the equator at noon. Nothing too chaotic going on there at the moment. Here's another diagram of the atmosphere, because we're going to show you the F ionosphere layer next. Here's a slice of the atmosphere. At about 300 kilometers, the vibrational frequencies of the bridge between space and Earth, the F ionosphere layer. And we're very close to an equinox. The most geomagnetically effective times of the planet are around the equinoxes. The moment that the sun passes the Earth's equator. Anyway, there's the latest image, 8:45 universal time. Things looking fairly normal there. A little bit of high frequency anomaly, nothing to write home about. Here is the Anomaly Map, which should help you new viewers who aren't used to looking at the ionosphere map. This is the departure in megahertz from the 30-day median. Mostly high frequency anomalies planetarily wide here, although some low frequency ones over places like the North Pacific, North Atlantic, and North America. There's the latest image, 8:45 universal time. Again, things looking pretty normal at the moment. And before we get to bonus features, thanks to our new Twitch followers, etc., follow us over there. It's the ultimate live streaming platform. Thanks to YouTube viewers. Tell your friends and foes about the channel. Press the share button. Leave us a comment. Share on your social media. Perhaps share on Mark Zuckerberg's Facebook page. Or perhaps share on Jack Dorsey's Twitter. Next, thanks to our patrons. Please cancel your Patreon before October 1st and become Smash Team members. The Smash Team is the true source of our content nowadays. And here's a little tidbit for the month of Smashtember. We're showing what gold and silver paid members actually get to see. It's stuff that nobody else gets to see. So join the Smash Team. There's a $2.99 and a $9.99 per month and monthly membership, as well as a paid up option, which includes some complimentary merch. The complimentary merch looks like this. It's quite spectacular. And for everybody who hasn't picked any out yet, who's signed up for annual memberships, drop us a line and let us know what you want. A hat, a girl shirt, or a t-shirt. Available in a variety of colors. And that exclusive design only available for paid-up members at the Smash Team. Smashomash.com/Smash Team. You can link to it on the homepage. Also check out our merch link. It looks like this. I'm currently wearing a Mensa hat, which isn't the organization for, well, it is the organization for geniuses. Gifted folks, yes. It also stands for Make Earth Not Suck Again, since it's up to you. Hey, look, it's the face of evil, St. Anthony Fauci. Are you familiar with the definition of the term fraud? It means an intentional misrepresentation of material facts. So I say to you, universum liberate. Respect existence or expect resistance. Here come bonus features. It's the El Teide ground-based solar observatory to see the latest imagery of the closest star in hydrogen alpha, 6,562.8 angstroms. It's part of the National Sunspot Observatory. Again, coronal mass ejection watch and solar flare watch in effect. Here come the rest of your bonus features. It's the latest intensitygram and magnetogram. Sunspot 2871 is still perfectly capable of producing major flares. Don't be surprised. This one looks like it's been degrading here. And these two groups over here have been degrading as well. Anyway, there's your full disk view. There could be some new spots forming over here. Again, I'm expecting to see some rise. Anyway, there's a colorized magnetogram, the latest refresh. And I don't know why we showed cosmic rays. Things were out of order. We're going to close things out with some composite imagery, some spectacular composite imagery. This is 1600 angstroms and 94. 1600 angstroms includes ionized carbon. 94 is ionized iron. You can see that M-class flare from Sunspot 2871. Here's a quick view of the northern hemisphere. Just give that a minute. Give me a minute to learn the English language. Give that a minute to initialize. There we go. And 94 angstroms is a great wavelength, folks. It takes 10 images per minute instead of only 2. 5 times more than most of the other wavelengths, save for 131 angstroms. And here's the southern hemisphere. We'll also do an extreme close-up in 94 angstroms to close out the video. Once again, congratulations on realizing our channel exists. As nuclear fusion certainly exists on the surface of stars. And here's some of it happening before your very eyes. A great close-up here of an M-class solar flare from Sunspot 2871. Again, visit our links, support our channel, especially if you'd like to see these videos continue to exist. And may that solar wind be at your back.